my name's Ahmed. I'm one of the MDs at Firemind, and this is Jason, one of my cloud engineers.
Yep.
We're an AWS Advanced partner. We specialize in data, AI, ML. And we're going to talk to you today about extracting, analyzing, and automating pipelines, data, documents with trained models. The reason I have Jason here is he's the one that does the hard work. So he'll talk a bit about the way we do things as well. We're going to cover more than just the models itself. So one thing that we're going to talk about specifically is the orchestration of these pipelines, and we have a demo as well. So before we get started, hopefully, if you have PDFs on your phone, ideally CVs, if you want to scan the QR code or go to redirect.firemind.com/D3, you'll have a nice UI. We'll come back to this in a moment. And what we want to do is kind of show you, again, how we orchestrated a simple demo that hopefully should run in real time, hopefully shouldn't crash, but feel free to hurt it because it should scale, right? And it should be just a little bit of fun. If you upload your CV, it should give you salary range, expected, the roles that we extracted out of it, to kind of show you how IDP can kind of work in a fun way. Don't worry about if you don't know the URL or the QR code. This will be on the next couple of slides as well, but you'll get your pseudonym, so everyone's anonymous, upload your document, your CV, and then you get your results, and we'll talk about it. So, before we get started, we just have to set a few ground rules and teach everyone to suck eggs. Has everyone heard of machine learning? Everyone kind of understands the concept. So when we're speaking to customers, they often think that machine learning is, the savior to everything. And we like to explain it in two ways, and I hope you can kind of all agree with these as well. Standard computation, deterministic computation, deterministic algorithms. No matter how many times you run the function again with the same input, you receive the same output. We call it like a binary response, a true or a false, 1 or 0. Standard API, standard computation, right? So that makes a lot of sense. And again, you can have deterministic algorithms as well, things that can kind of help customers process their data, but it's not necessarily machine learning as we kind of like to see it. But then this is how we explain machine learning. It's probabilistic, and I hope you all can kind of agree, right? The idea that you receive a probability based on the input. And even if you run that input again, in theory, the probability could change because of parameters, training, etc. And we talk about this compared to black and white binary as lots of shades of gray. This is how we explain it to customers that may not be technical, may not have like a data science background. Just they understand, and what we say to them is, you need to accept the acceptable gray within your solution, because in theory, machine learning will never be, or should never be, completely black and white. So, why should we care, and why are these things important? And ultimately, we speak to customers and we say, it's about helping drive the business forward. So one of the key things is automation. As we all know, machine learning, through providing proper probability with models and data input, helps us automate simple and complex tasks, better operational excellence. So processing documents, like for example now, you're hopefully all uploading your CVs. Instead of someone parsing those CVs manually, we have a machine, hopefully, doing the hard work and then providing some kind of output. So we're automating, we're driving operational excellence. We're making predictions, so we're running abstract mathematical computations on large data sets. Again, that could be incredibly time consuming. The data sets could be very abstract, and you could have lots and lots of recommendations as well, from real time to large batch inferencing. And again, this predictions is what helps customers look forward once they look backwards on their data going forward as well. Discovering segments, sorry, this is a bit low actually. So here's a really interesting one where we can have machine learning models discover things that customers may not know exist in their data. We had one particular customer that was really interesting. They sold wine, and they told us, Merlot is a Christmas wine. You drink it at home, in front of the fireplace, with the Christmas tree. But then someone else said, actually, Merlot is a summer wine. So half the organization thought wine was in a different ways. And again, we use machine learning to discover these segments, because going off that, we know our customers, probably isn't good enough anymore based on the data. And then improving inputs, and this is a really interesting one now, especially with the whole Gen AI. The data you have could be terrible. The number of calls that we've sat on where a customer said to us, oh, thousands, tens of thousands of rows of data, but actually 1% of it is good. It's okay, well, what do we do with that? So we can implement machine learning to utilize things like NLP. And what NLP can then do is it can improve the inputs, generate new sentences, for example, predict missing parts that will help move that model forward, will help discover segments, make predictions, and drive automation and operational excellence for that business going forward. Yep. So how do we use trained models? And we're talking about IDP specifically here, because one of the big things that we do for a lot of our customers is intelligent document processing.
Yeah, it seems to be like very popular. I think most of our customers we've dealt with need some kind of IDP, right? So yeah, it's very, very common, and but it's common but different. They're always slightly different, and that's I think that's some of the challenges we take on, and we see new things to process every time we do one of these projects. So it's quite nice.
And absolutely, Jason's right. So Jason would have worked on ones, and you can talk about probably a few that you've done, because this is how we explain it to customers. Although it's probably a bit ironic, the idea is that magic occurs here based on the input and the output.
Yep.
And that goes from things like financial input, scraping input, for example, receipts, invoices, handwritten input as well.
Yep.
Some of the projects you worked on.
Yeah, because for most of these, right, the processing was always different. That's the key here, because IDP, the flow, generally speaking, is the same, but the processing, the data itself, is you know, it will change all the time. So processing is different, post-processing is different, ingress out, egress might be different as well. But generally speaking, IDP, the flow is the same a lot of the times, and we need to manipulate the flow based on what the data that comes in, and that's what we've found. At least I've found with customers I've worked with.
And then the interesting part, exactly like Jason said, that manipulation spans a number of services.
Yep.
And specifically what we're going to talk about here is how we utilize these services and orchestrate them to do different things ultimately.
Mm-hmm. Yeah, so you can see here, I mean, it shows, right, I don't have to explain this in too much detail, but you can see there are different services for all the things that we do for ingress processing, pre-processing, egress, so on and so forth. It's just taking these combination of things and making it work for the customer based on their data. And again, data here is the key, right? Depending on what you're giving us, we can use the best service to be able to process it, whether it's, you know, large data sets, small data sets, you know, the data is complex, it's not that kind of thing. We will use these things to try and get you the best result ultimately, and that's what IDP is for. And a lot of the customers now are utilising what we've implemented for them because they've seen real value in IDP ultimately, which they wouldn't have found out otherwise.
And just while we're here, while we're getting technical, don't feel like it's Jason and I talking at you. Interrupt us, ask questions. We're going to quickly go through an orchestration one, but I think it's important to talk about why we split bits like this, and again, how taking these services, and I always talk about the concept of soy sauce, where you go into Tesco, you're hungry, okay? Soy sauce is edible. You can go get some soy sauce, you can drink soy sauce, but it's probably not a good idea. So again, it's the same thing with AWS. There are so many services. Even us that are working on a day-to-day basis with AWS can't always keep up. So sometimes what we help our customers do is understand that soy sauce, you don't want to drink soy sauce, you should probably use something else. And this is where we talk about orchestration afterwards. Mm-hmm. But the key thing here to remember with any kind of IDP processing, ML processing, is that Amazon is event-driven. We use S3 as upstream and S3 as downstream. Generally is always the best way.
Yeah, yeah. You can see here we've got DynamoDB on the end as well. A lot of the times with our IDP solutions, you want some kind of metadata or auditing. Mm-hmm. That's where we use DynamoDB because that's actually quite useful because you can see a trail of what's happened to your documents as it's gone through the entire pipeline. So yes, you'll have your final outputs in S3, great. But if you wanted to see why this document has failed or why this document has done this in this part of the pipeline, DynamoDB is great for just holding state in that instance. And we use that quite a lot generally to be able to audit all of these things.
Absolutely, especially if you want to implement human in the loop as well.
Exactly, yeah. So again, you can modify DynamoDB if you want to change some values. You know, as Ahmed said, human in the loop. If you've got a human reviewer, he's denied a document because it's not being classified correctly, you can set up triggers to change those values in DynamoDB and go from there. So,
and again, something we haven't mentioned here particularly yet, because this is kind of just a document flow, is what that retraining gate looks like and what tools may exist. And some tools are Amazon-based, some tools are not Amazon-based.
Yeah, so it really depends on the customer, what they feel more comfortable with, but at the end of the day, it can ultimately be integrated. Depending on the success, I don't know. Like I said, Amazon do a pretty good job of it, but we've integrated some third-party tools, and it's worked just fine. So yeah,
absolutely. And then the reason why Jason is here, and the key thing of someone like Jason is so important, something like this, is defining orchestration. Again, it's very simple, and we've had it on several projects where a customer will come along and they'll say to us, here's a notebook, here's an EC2, here's a Python script, for example, and it's generally doing what we're asking for, but it won't scale. Mm-hmm. And that's where someone like Jason will dissect all those components, produce a pipeline, mm-hmm. and then make that pipeline work into something that will scale for the customer.
Yeah, so there was a customer recently who had, as Ahmed said, all the code. It was in a big notebook. It's very monolithic, very big. It had all the components it needed to do an IDP solution. But as Ahmed said, it didn't scale, right? It was very hard for them to change these things because their code is so huge, and that And one of the suggestions, the first thing I suggested them is, if you can break down your code for me, we can put it into these little components. For example, these Lambda functions. Break them down, put them into Lambda functions that do one very specific thing, and you can then scale as much as you need, right? And it's easier to manage the code, and also for scaling. If you want to add more components, it's much easier to do it as part of step functions, Lambdas, because you can just chop and change as you need. And that's the beauty of breaking down code ultimately, and your processes. So I think generally speaking, that's just a good process, not to have monolithic.
But then there's complexity, right?
Yeah.
Because this is a lot of things. And again, the discussion we have with the customer is, well, I have a Python script. Why do I need all these things?
Yep.
So why do we talk about these things that run in step functions? Why do we talk about lambdas and storing metadata? What does that help them understand?
So it's a different way of thinking, right? This is the way you should think about this is, if this product was to get any bigger, can you manage it, right? So it's great to have one member of the team manage this code, but let's say if that one member of the team leaves, what do you do then? All they know is on this one big notebook or Python script. And so to be able to break it down, me as someone who's never touched that code, I can look at their, pre-processed code and look, okay, well, this is doing pre-processing, great. Can I look and see there needs to be a variable that needs to be changed, or I need to change something? I then know that whatever I do is isolated on that one thing. And so having these segmented modules to do the work means you can customize, and it's very easy for me to then come in as someone who's never seen the code and see, okay, well, if I want to add a process just before inferencing but just after pre-processing, let me add a Lambda function, my own Python script that I can add, and it will just make sense, instead of having to sift through hundreds of lines of code to try and figure out what's going on, right? And so the beauty of step functions is each stage you can append and change the inputs. And again, we don't have a demo for this, at least we don't have I can't show you the payload, but you can take segmented.
You have a demo, but you can't show the payload.
It's all in the back end, right?
Yeah.
But I'm a big advocate for step functions, because I think for general processing, for workflows, I think this is the process, or using step functions is going to be a big thing going forward, I think.
And here's the interesting part, because you're saying this as a cloud engineer. Mm-hmm. Who here has dealt with step functions, dealt with infrastructure as code in this sort of way? Just hands in the air, just an idea. And what's your main role? What would you say?
Data science side, so I'm trying to fit in with someone else who's working it, and it's just connecting all the other points of view as possible.
And how do you find that?
Varies.
And that's the interesting part, right? Because as data scientists, sometimes you're at the mercy of IT, right? And IT mainly, and nothing wrong with that, they, not slating IT, but they'll say, here's an EC2, go knock yourself out, right? And okay, that's okay to a point, but that doesn't scale. So our niche, where we fit in, is we bridge those gaps together, because we're not expecting data science teams to understand the nuances of infrastructure, right? Like the soy sauce analogy, that's the idea here. And by integrating what we understand about data science, by integrating what we understand about infrastructure, this is where we say, this is what scalable looks like, componentization. Because this revolution almost happened in engineering 10, 15 years ago, when people started modularizing stuff, CI/CD, etc. And the thing that we advocate for is taking all those learnings and applying them to the weird and wonderful world of data science. And the key thing here really is step functions. Because recently, after reInvent, an announcement was made about this optimized integrations. Before, step functions really just ran a Lambda, and then you kind of did stuff with a Lambda. Now, step functions supports 3 ways for you to natively call AWS services. You can say a little bit more.
Yeah, so as Omar said, like, running Lambda is great, because ultimately speaking, if you can run a Lambda, you can run anything in AWS, because it's just a case of calling an API in AWS to be able to do whatever you need to do. But step functions has improved a lot since then. And as you can see, there are different ways of doing it. One of the biggest ways I do a lot of my processing is async, because ultimately you want to just fire a job and wait for it to do. So ultimately what you're doing is firing off a job to, I don't know, textract, comprehend, and then that Lambda that runs that process finishes. So you're not paying for that anymore. You're just letting the payment of textract be the only thing that's happening, which is good, right? This is what you want. You want to fire and forget. When it's done, you can then receive a payload and say, okay, this is done. Then you continue the process. This is a big thing that I use quite on a daily basis, but you have other options like run sync jobs. So if you need to wait for a response from the API or the service you're working with, that's also an option. And then this one, request response. I don't know how new this one is, but this one is native integration with services. So you can directly call services without the use of a Lambda, for example. So there are services that AWS are adding, and I assume are going to still add, where you don't have to even write the code to be able to invoke the API. You can just call the service directly.
Yeah.
And that's becoming quite a common thing as well. I have used that, and it's quite handy. So for textract, hi.
Yeah, just one question, because we have some batch jobs that we're running,
Yep.
and we considered step functions, but looked at the pricing model, and for the number of entities we process in a very short time, it looked very expensive, so we didn't use that.
So-
your view?
So I personally, I don't think, I mean, from what I understand, step functions are as expensive as running a single Lambda. I think you get 1 million requests free in the free tier, and then it's like pennies afterwards. But again, it depends. I can't say for sure.
The AWS cost calculator is a dark art.
Yeah.
I'll be honest. It's a very dark art. But we do real-time inferencing using sync, and then batch inferencing using async. And again, because these are architectural questions, it's sometimes unfair for data scientists to have to answer it, because just remembering off the top of my head on the calculator, there are state transforms you have to put in, invocations, etc., and the services that run, for example. This is where you would work with a partner, because when you work with a partner, we would say to you, okay, if this is what you're trying to do, this is the architecture, this is how you'd price it. But furthermore, when you work with the partner, there's always things like credits and funding incentives as well. So when you want to run a POC, we can hook something together, get some credits from Uncle Jeff, and test it, and then kind of take it forward. But you're absolutely right. When you look at the face of a lot of these things, and it was interesting, I was at a roundtable yesterday around databases, and we spoke about the pricing around databases and serverless. It's very much like a bit of magic. It's very easy to see, oh my God, this could cost a lot of money. But this is where we can help, and we help customers understand that. Because what we do with examples like this is we'll say to a customer, for example, your current process costs this much. And because it's running on an EC2, it's a constant cost, and it's a bottleneck as you scale. But when you achieve $1 million per month or $1 million per year or whatever, based on the optimizations put in place, this is your X by Y. X being a cost per running a test or running a batch or running or whatever, and the Y being your cost to your cost to Amazon, how much you're going to be charged by Amazon. So you can turn around to your stakeholders and say, actually, at scale, if we do achieve $1 million a month, for example, and each invocation is 2p, you then know how much to charge your customer. That's your margin. And again, this is the advantage of working with a partner, because we'll work out all those business parameters with you as well, so you understand the kind of the best way to implement it. Excellent. So how do we use it? So again, this is an idea for what we do with customers. And this is generally the approach that we take for the majority of our step function processes. This is quite abstract, but again, we believe in the idea of you start big and then you kind of optimize and delete away. Because you don't know what you don't know, especially around the data science process. You've worked on projects where a customer has come along and they've had a massive GPU instance, but after looking and criticizing the code, you realize 90% of usage is converting Excel files.
Yeah. Their code ultimately, they were burning money. Ultimately, is the way we looked at it, because they were running these GPU instances and realizing actually their code doesn't need a GPU at all. And so it's one of these things that you don't know until you ask, right? And that's what we found. And we ultimately optimized their solution from going from EC2, which is they were paying for it. They had someone to switch on the EC2 when they needed it, switch off when they didn't. We then implemented step functions in Lambda, because Lambda don't need a GPU. Lambda serverless. It will start and stop. It's event driven, and we just saved them so much more money just because they asked us, and we helped them build the system for them, which then automatically started their processes and switched off their processes when they were done, and they weren't paying for a GPU. So,
but the interesting part there, and the reason why we show this as a high level example, is because when we look through the code, we go, okay, you're doing several steps. So in this example, we silo the storing of metadata, the interpreting of documentation, before it's then sent for enrichment. And enrichment could mean things like, for example, connecting it to an SAP database, connecting it to a finance system, connecting to a HR system, for example, and bringing those predictions and adding real context to it. Post-processing can then be further joining, for example, and then human-in-the-loop can then be used for validating and training. And we had that for one customer where they were doing something, I think it was notebooks, and we moved it to serverless comprehend with some retraining as well. But yeah, as you can see, like the flow is, as I said, is pretty abstract, but this is ultimately the flow is the same. It's what you do with the components in between that can change. But yeah. And the magic here, because this is all infrastructure as code, because it's all deployed via CI/CD, and the data science process fits into it, everything is versioned, everything is accessible, everything scales, and more importantly, you have that audit history to go back in time and understand what it is. And sometimes through these optimizations, so us being a partner, there's lots of partner programs you join. One of the main programs we have is something called Graviton Acceleration. So you guys have heard of Graviton, ARM, for example. So Amazon has a CPU that you guys can use on most compute, which is ARM64. Now, what we do with a number of customers, generally, if they're using, actually, hands in the air, who has written multi-threaded Python? Okay, perfect. So one person. But in general, if you're doing single-threaded Python, you can probably run it on ARM, which is a lot cheaper. And sometimes what we'll do with customers, actually not all machine learning requires GPU, for example. So we'll sit with the customer, we'll critique the code, we'll critique the algorithms. We go back to the slider saying, is this really deep neural network, for example? What does it look like to run it, for example? Do we need multi-threading, or can we get away with single-threaded instances? How can we optimize your pricing as best as possible to give you that best X by Y that you can take back to your business? And that's another key thing to think about. This is, again, you're in a shop and there's so many choices, and it's understanding what does that choice look like at scale. Yeah? Cool. So I hope that the demo has worked.
Fingers crossed.
Fingers crossed, right? So I'm hoping.
Go back to the previous.
Yes, of course. Yes.
So in the Lambda, I think the memory limitation is 10 gigabytes.
Yes.
Yeah. So if we have a Python function that basically uses much more than that, so do you have any solution?
Parallel scaling, right?
Yeah, so Lambda is just an option here, but you can actually integrate things like ECS.
Absolutely.
And ECS is, we run Fargate a lot of the time, and that will run for as long as you need and has much more memory. So
Use
ECS,
batch as well.
batch, ECS, Fargate, batch, all of these things. Lambda is just an option. It's the one we see the most common, but yes, as you said, if memory is an issue, we can integrate other services like that. So that's also an option.
And a really interesting part there is that when we do things like Lambda, Fargate, these are generally things that they're treated as on demand. So you can optimize the pricing with things like cost savings plan. Batch is a really interesting one because we work with one customer who we primarily use batch. And batch, we can use this concept called spot pricing. Do you guys know spot pricing? So then you're almost paying 30% of the on-demand price by doing it at certain times. And the key thing, the reason that people like Jason are so valuable is because they'll work with you on what that process looks like. A lot of the time we'll split up whatever's happening on those machines and say, well, actually, could we distribute it? We always talk about the concept of what does scaled processing look like? So waterfall, series, or parallel, and how we optimize that across the step functions. Because the more granular we can make the processes, the more that we can store states in S3, for example. That means if we do use things like spots and they're taken away, we pick up from where we left off instead of at the top of the pile. And it makes the whole experience a lot better.
But you said that you can optimize Fargate, but how you can optimize Fargate from the cost perspective? It's model, like you're paying for what you use basically, compared to ECS that you pay for a dedicated, for allocated instance that you put into your cluster. So what do you mean when you say that we can optimize Fargate?
Yes, so Amazon has this thing called a cost savings plan. So there's kind of three cost optimizations for AWS. If we ignore things like architecture and sizing, one is the traditional one, reservation. I have this EC2. I know what I'm going to use. I'm going to have it for a year or 3 years. This is the traditional approach, I would say, if you're running like a traditional web shop or whatever. The second one is spot pricing, which is on-demand pricing. So again, where I want to run this at certain times and I can batch my stuff together. It's a bit more complicated. The last one, which is the one that I prefer because I like to be lazy, is called a cost savings plan. So what you do is you say to Amazon, actually, I think I'm going to spend this much in compute over a year or over 3 years. And then what they'll do is you pre-buy that compute, including EC2, batch, Fargate, Lambda, whatever. And what they do is Amazon give you a cost reduction, and that cost reduction could be up to 70% off the on-demand price, including things like Fargate. Because when you use things like Fargate and Lambda, generally you'll be spread across all the availability zones on AWS, and generally some hardware and some AWS zones will be used less. So the cost savings plan will help you save all that money as well, without you having to think about anything like that. And sorry.
And what if your estimations are wrong and you underestimated?
You just buy some more. So again, this is the advantage of working with a partner, but also working with an SA. So we have these great people there in the corner with their AWS badges. They will talk, I hope, all day about the ways that we can save money ultimately. But yes, that's the key thing. Even with reserved instances, there are ways that you can upsize or move them. It's just a support ticket. And generally, I imagine if you're all working on Amazon, you will have a customer SA and a customer account manager that you can just send these questions to. But again, when you work with a partner like us, you'll have someone like Jason on Slack or other Jason. We have 2 Jasons in Firemind. That's the other one there. And you would message them and say, we've used our cost savings plan. What do we do? And Jason will sit with you and they'll go, okay, let's devise a new one. What does that look like? This is what we can do going forward.
Thank you.
That's okay. It's the same thing with databases as well. So probably databases, it's easier, I guess, to understand what the fixed storage state looks like. And then again, with things like, I've got on here, S3, go back here. Oh no, this one, there we go. S3, for example, you have so many storage tiers on S3. Brilliant one called intelligent tiering, where you just chuck it in there and
It'll do the work for you.
It will do the work for you.
It will push it into a state which is basically going to optimize the cost for you storing it there. So it's good.
So the reason we don't show things like EC2, or the reason that we don't say that we deploy things like EC2 is because, again, I want to be lazy. I want to let Amazon do all the hard work for me. I want them to patch these services. I don't want to worry about CVEs or anything like that. I want to say, here's my infrastructure, here's my code, here's my data, go do the hard work for me, scale it for me, give me the best price. If it has to be an interruptible workload, let me pick up where I left off. And again, it comes back to the soy sauce analogy, right? You can make a dish in so many ways, but when you make it the way that
It's meant to be.
you want to offload everything, it becomes a lot easier.
Yeah.
Yeah? Cool, all right, crunch time, demo time, right? So I hope everyone hit this URL. Hopefully you would have had your pseudonyms and everything would have appeared. Let me just jump on here and have a look. So for those of you that haven't done it yet, I'll show you what you're missing. Just share my screen. So let's jump out of this. So you'd have something like this. And you'd come along, and I think I've got a CV somewhere. Let's have a look, and I'll upload my very old CV here. And you should be able to upload it. Fingers crossed, there we go. And then you'll receive a pseudonym, which hopefully isn't a swear word. And then you'll receive some stuff.
So essentially, if you upload your CV will have, my assumption is there'll be skills. Obviously, one of those skills was Azure. It's gone now. Ajax, there we got Ajax on there. But it's extracting those skills, and then we are sending it through. What we're basically doing, we're extracting and then we're comprehending that data, and then we are uploading it as a word cloud.
And all we wanted to show here again is kind of like you were saying. Take some data. This is completely unstructured data, right? We don't know what's in your CVs. We have a general idea. I don't know if anyone uploaded an Azure PDF for all we know, right? But we're taking that information. We're trying to grab the information. We have the other. No one's other at the moment, which is quite interesting. Yeah. And we're trying to just grab some information, right? And location's a really interesting one. So location could appear in so many different ways on a CV. Sorry, I've got my 30-second refresh. And how we show that information going forward. And this comes back to the point of exactly what you're saying at the start. The process generally is always the same with IDP. But when we sit down with the customer and try to understand the nuances, the business requirements they kind of go forward, how that kind of helps them, and what process optimization that is as well. I'll go back to the deck. I've got a few more slides. Any questions on that as well? If you stick around later, we can show you through the step function code if you kind of want as well. So then just really quickly about us. So we're Firemind. We're an advanced partner. We specialize in data, AI, ML. We always talk about a modern data strategy, and this is key for every business, startup, SMB, enterprise. You have to be thinking of what does your flywheel of data strategy look like. And in this, we have machine learning, databases, analytics, etc. But again, it's very easy for us as engineers, data scientists, technologists to crunch some data through and bash out some models. But when we're speaking about things like certifications, SOC 2, ISO, corporate compliance, for example, we have to think about governance. We then have to think about cataloging, because at the end of the day, there are going to be people, apps, and devices that will use the things that we use. So how do we ensure that data's safe, it's governed correctly? We have lineage set up in place as well. So here we help customers understand the best way to utilize a modern day strategy for operational excellence, process optimization, decision making, and improving customer satisfaction. And again, the other reason I have Jason here, not just because he's there to look pretty as well. Jason was the chief architect for a lot of these landing zones. So these landing zones are actually on our GitHub. So if you go to github.com/HelloFiremind, if you scan the QR codes, it will take you to a calendar link where I can send you all this information. But we have these landing zones, open source on our GitHub, that again show how we do stuff. And again, one of the essays was discussing downstairs, ML starts with data. And one of the key things we have with lots of customers as well is, what does a good data landing zone look like for different data sources? And again, here you implemented this, right? So you can talk a little bit about how we ingest it, for example, and take it forward.
Yeah, so again, for the data landing zone specifically, it's very similar to IDP, I guess. You ingest through S3. We then crawl the data, so we use Glue in this instance. So Glue's an ETL tool within AWS.
Who's used Glue, by the way? How do you like it?
It's okay.
Okay, that's the right answer.
That's the right answer. Yeah, that's what we want to hear. Okay, yeah. So we use Glue. We crawl the data. We grab a schema from the data. We do some ETL on it, and then it becomes available for us to do some querying. So that's ultimately the flow here. You can see here that we've done. But the idea is, again, we try to make everything customizable as much as it's feasibly possible. Because the good thing here is ETL will always be different. So you need to be able to customize. And so we've integrated step functions in our data landing zone, but we're just chopping and changing the services we use. So in this instance, we're using S3, Glue, we're using Athena, that kind of thing. We can integrate QuickSight and, for the analytics. So again, the step function again is the back end, but actually we are changing the workflow. In this instance, it's an ETL workflow for our data landing zone. So it's all open source, so if you want to have a look at my code, feel free.
Yeah, but again, we built it in the idea that data sources come into S3, data egress comes out S3,
Yep.
and we've integrated Athena. You can put in your BI tools, you can implement Redshift, for example, and then real-time data through Kinesis. So it's all there. Another one we have as well is MLOps. So again, we're taking the kind of CI/CD revolution that happened in engineering 15, 20 years ago and applying it to machine learning. And you will hear MLOps every now and then and what that kind of means. To us, it means taking machine learning and deploying it, right?
Doing some stuff in the middle.
With some stuff in the middle, with some magic in the middle. When we speak to customers, we always talk about 3 levels of ML, especially on AWS. And this is again how we like to convey ourselves. Step 1 is this: forecast, comprehend, personalize, text extract, whatever. These are ML as APIs, right? You can throw garbage at personalize and it'll give you garbage back, right? You don't have to worry about anything. It's all there for you. You don't care where it runs. Amazon does the hard work, yeah? So this is a great way to start with ML, really, because there's no thought process.
It's managed,
there.
yeah. It's a managed AWS service.
But again, this doesn't mean that this is bad, because we heavily use comprehend. We heavily use text extract, for example.
It does a good job considering it's managed. You know, like considering it's not specifically custom per se. Like you can have custom comprehend, but the stuff that comes out of the box actually is very good. It's a very good, and we've used it for customers in the past,
Yeah.
right? So
don't think because it's level 1,
Yeah.
it's not very good. Sometimes we have to do something a little bit custom, not too custom.
Yep.
So we call this level 2. SageMaker has this brilliant thing called pre-built containers. Anyone use a pre-built model, pre-built container on SageMaker yet? Perfect, right? We don't have to build anything.
No.
We just give it training data, validation data, off we go.
Yep.
And again, it integrates into SageMaker as well.
Yeah.
So actually, this pipeline on our GitHub has a pre-built TensorFlow model,
Yes, yeah.
or Scikit, I can't
Yes,
remember what it
it's
is.
TensorFlow and Scikit both, yeah.
And it has example data, and it shows the magic again of integrating into the SageMaker ecosystem, and how that then deploys stuff out. And then sometimes we'll have some customers, because every customer is the unique snowflake they are, who wants a completely custom model. So again, we'll implement a lot of the learnings that we understand of how SageMaker likes to work with models, because again, we want to be lazy. We don't want to host these models ourselves. We want Amazon to do the hard work for us, right? And then we implement it into this platform that does ingestion, processing, all the way to evaluation, including a human-in-the-loop step as well for model evaluation, right?
Yeah, yeah. So a lot of customers, sometimes they want to validate the data that's come out of their pipelines. And again, generally with step functions, you can integrate that. So you can have, you can notify a team of validators. Step functions will send that notification to say your data is ready to be labeled. You do some labeling, they say approve, great, sends back to the system, and then you continue on to the journey of hosting the model, right? So that's also an option, and becoming more and more common. So,
But even before that, this provides a flywheel for ML, because what you have at the evaluation step is you have a stop in the process where you're presented with the F1 score and the recall, I believe, where you can then say, okay, this model has improved. I do want it to go to production. And again, this follows the CI/CD mentality of having gated approaches, kind of how you do Git flow for engineering, right? For ML.
Yeah, so you can basically fail a model as many times as you want, but you know that whatever's hosted is not at risk, because until you approved the model, you know, if the model's good, then only then will you host it, and that's just versioning, that's version control, that's controlling your pipelines.
And we use this day to day. So for example, the CV model that we use was hosted on a serverless inference on SageMaker, which this will then output to, for example. You know, so before we came in, we
which is actually a new thing, right? So SageMaker serverless, and this was quite cool what they've done. So generally speaking, in the past, when you would host an endpoint, you'd be running for the entirety of that endpoint uptime. Basically, you're paying for uptime for the whole period. But what they've now introduced is serverless endpoints. So if there's no traffic to that endpoint, you're actually not paying for it, which is actually very good, because you know endpoints can get expensive, and if you're not going to use it, it's good that you don't get charged now. So that's what we're currently hosting. That the demo you saw. So that front end, all the stuff that's getting sent to is on a serverless endpoint. So my assumption is because there's no traffic right now, we're not paying for it.
It will start cooling down.
Yeah, it will start cooling down, and you know, you save money.
Absolutely. And then lastly, something that isn't on a GitHub, but something we offer to our customers, is we have the IDP Platform Foundation that we you know, build a demo off, for example. We work with a majority of our customers, right? And again, it works with that same idea. We take different input documents, which could be completely contextual to the customer, could come from different systems, whatever. We run it through our kind of IDP flow. We support several languages. Actually, we support more because I think Comprehend only supports a number. But the reason for the presentation here was to say, actually, by using step functions, if, you know, for example, Comprehend doesn't support Swedish, one of our customers requires Swedish IDP workflow. Now, there is a Alberta model for Swedish language. We obviously can't use Comprehend for that. We use step functions to invoke something, to bring back the information, and it just slots in.
Just a third-party, like you just call a third-party thing that will, you know, in your backend system, like I said, the Swedish thing, it just calls another system, and you continue the workflow in AWS.
Absolutely right.
With no problem.
And that's the idea of taking it that way and then providing output that's then required for that business to improve their workflow, improve their automation, improve their predictability.
Yeah, exactly. And step functions can be as simple as you need them to be, or as complex as you need to be. That's what I would like to drive home here, because actually you can add as much as you need to make it as complex as you need, or you can have a simple workflow, input, some processing, some output, and it can be as simple as that, and you know, still do a good job of it. So, yeah.
Absolutely. And that's it. Thank you for listening.